Alright, welcome back. So before we have mentioned a lot about how to store data into the disk as well as hard drive and for the database system. And later on we will decide to talk about something about record modifications. It covers both insertion, deletion, as well as updating of the record we have in the DBMS. Because for the data we store in the DBMS, the updating as well as some other modifications, they may happen very frequently, and it may also create some challenges for us because we may need to deal with the data we have stored in the disk in the real world. So how can we do this kind of modifications from a logical perspective to the real concrete physical storage data we have there? It will be a very interesting problem. So here in this page we show how to do the data modification by inserting some new records into the DBMS. It really depends on the file, how we organize the data we have and how we organize the files. If all the files in the DBMS are unsorted, in other words, we maintain a heap file in the DBMS, then it will be very easy, right? It is a heap. Then we can just add these kinds of new inserted records to the very end of these kinds of heap files. It is very straightforward, also very easy. However, if this file is sorted, it will be more challenging, right? It's just like if we have a list of numbers and we decide to insert some new numbers into it. Depending on the list is sorted or not, if it is unsorted, we can just find a new place to put this new number, right? However, if this list is sorted, then we may need to decide how to handle it because we need to keep this list to be sorted after we do the insertion as well, right? It will be very similar here. If the files we are organizing are sorted, then we need to decide the right place how to insert this new record. So we may have different cases, right? If there is space for the new record in the right block right now, if so, then we can just directly insert this record into the right block directly. In other words, we are very lucky. We have a right place for the new record. We just store it there without doing any extra operations. This will be very easy right now, right? However, if we have some other cases which may happen with high probability, like we find the right block for the new record. However, right now this block has been occupied, and then we can further check if the nearby neighborhood, if they have any space or not. Right, we try to find the right place, position for the new record, and if we find it has been occupied, then we can check the nearby these blocks if they have space or not. If so, then we can just slightly shift the current or the data we have either to the left or to the right, right? And we can make a space available for the new record and then insert it there. However, here we normally just check the nearby, the neighborhood blocks, and that is one block or two blocks. And we don't need to check with the blocks which are very far away, right? Because it will be more complicated. This is not the case we may encounter. However, sometimes if we are very unlucky and we find the right place has been occupied, also nearby and the blocks they are all full, then how can we handle it? So the way we can do is very similar to the hash table that we mentioned in the undergraduate database system, is that we can create an overflow block instead. For example, if we are inserting a record into the block, right now the block has been occupied and all the nearby the blocks they are all full, then we cannot do any shifting, we cannot do the insertion directly. The way we do is that we can create one overflow block just following the right block. We can create a link pointing to the overflow block for the current block, and then we can insert the data record into this overflow block in a similar way, just like before. In this way, we can insert this new record into the database system very safely. And it will also create some problems because normally we don't like this overflow blocks to be very long, right? Because it will create lots of problems for us to search for this kind of data. If this block is very long, then the search process or search time cost will be very high. Okay, this is for the insertion. Okay, so besides insertion in the real world operations, we may also need to delete some records, right? So the deletion compared with the insertion will be much easier. We just need to free the space in the block. If we need to delete a record in a block, then we can just free the space for the record in the block, right? And sometimes we can also shield the records as well to make them continuous to each other. If the record happens to store in the overflow block, and after we free this space, then this overflow block becomes empty, then we can also further eliminate these overflow blocks as well. So actually deletion will also cause some problems because as we mentioned before, if we delete a record and we may have some other records pointing to the one we plan to delete, right? It will be a problem. In other words, we may have so many floating pointers. Actually, in the real world, we can never really eliminate the record because others may point into it. So instead, we can place a tombstone for the record instead, which will be a null record. And there will be some trade-offs. It really depends how expensive is it to move valid record to the free space for the reclaiming, right? As well as how much space is wasted. So we need to delete record, delete fields, as well as free the space claim, as well as freeing the space change as well. So all these operations will be very expensive. It will be a balance between how expensive these operations are, as well as how much space we are wasted. Okay, this is about deletion. Another operation we can have is called updating, right? So if we decide to update a record with a new one, it really depends, right? If the new record we are updating is much shorter than the previous one, it will be very easy. We can just replace the original one with a new one. However, if the new record is longer than the previous one, we probably need to make more space for it, right? So we can put the new record into it. And we may need to shift the record, create the overflow blocks for it. So it will be more complicated. Okay, so this is about the way we can do to handling the record updating as well as the insertion deletions, which happens very frequently in database systems for the record modifications.